Hello everyone, welcome to our first session on Introduction to PDE. In this, we are going to see what is a PDE. A PDE or a partial differential equation is an equation that involves partial derivatives mainly of an unknown function with respect to two or more independent variables. So the main difference between ODE and PDE is in ordinary differential equation that function involves a single independent variable. Here that unknown function involves two or more independent variables. So here we see one simple example of a PDE, that is the one-dimensional heat equation, which is represented as dou U by dou T is equal to K into dou square U by dou X square, where U is a function of X and T, that is the temperature at position X and time T, and where dou U by dou T gives the rate of change of temperature over time, and dou square U by dou X square is nothing but the curvature of the temperature profile in space. So here we see the key differences of ODE and PDE. As I said already, ODE involves a single independent variable, but PDE involves two or more independent variables. And here the derivatives are known as ordinary derivatives. Here the derivatives are called partial derivatives. And this is one example for an ordinary differential equation, that is dy by dx plus 3y is equal to 0. Here we see how to denote the derivative, and this is an example for a partial differential equation, that is dou u by dou t is equal to k into dou square u by dou x square. So this is how we are representing a partial derivative. This is with respect to x and this is with respect to t. Solution here involves a function of one variable. In PDE, the solution involves a function of two or more variables, and application can be found in finding the motion of a particle. Here the application can be found in heat conduction. Some of the applications of PDE. The partial differential equations are the heat equations, wave equations, Navier-Stokes equations, Laplace or Poisson equations, optical flow PDE, and drift diffusion equations. All are partial differential equations, and the applications of these equations can be found out in these fields. For an example, the application of heat equation can be found out in processor cooling, image smoothing, and chip thermal analysis. Here we see what is the order of a PDE. So the order of the PDE is nothing but the highest order derivative occurring in that PDE equation. So here we see one example, that is dou square u by dou x square plus dou u by dou y is equal to 0. Both are partial derivatives, in which the first one is the second order derivative and the second one is the first order derivative. So order is nothing but the highest order derivative, and so the order is nothing but 2. Here we see what is the degree of a PDE. So the degree of a PDE is nothing but the power of the highest derivative occurring in that PDE equation. So this is an example to that. So here we have one PDE, it is dou square u by dou x square the whole power 3 plus dou u by dou y is equal to 0. The first one is the second order derivative, the second one is the first order derivative. So that for degree, first you have to see the highest order derivative occurring in that equation, that is 2, and the power gives the degree of that equation. So here 2 is the order and 3 is the degree of the PDE. So after which we come to the formation of PDE. The formation of PDE can be done in two ways, either by eliminating arbitrary constants or by eliminating arbitrary functions. So here we see the steps to eliminate the arbitrary constants. We start with the given relation involving independent variables x, y and dependent variable z. That is, throughout this we consider z as a function of x and y, where x and y are independent variables and z is called a dependent variable. So now we differentiate this with respect to x and y partially. We get two more equations, and using the resulting equations, elimination of the arbitrary constants gives our resultant PDE. In a similar way, we can eliminate the arbitrary functions to form our PDE. For we start with the relation involving an arbitrary function of a combination of variables and differentiating that function with respect to each independent variable. We'll be getting further equations, and by eliminating the arbitrary function and its derivatives in the resulting equations gives our resultant PDE. So in our next session, we'll be seeing how to form a partial differential equation. Thank you for watching.